Hey everyone, welcome back to the Deep Dive. Today we're plunging into something truly transformative, how software itself is fundamentally changing. We're drawing heavily from the incredible insights of Andrey Karpathy, former head of AI at Tesla. He argues this shift is unlike anything we've seen in, well, the past 70 years of software development. Feels like we're rewriting the rules from scratch.
Yeah, that rewriting idea is spot on. The pace of fundamental change right now is it's astonishing. We're not talking about like a new feature update here. It's a complete redefinition. How we conceptualize, build, interact with tech. It's all up in the air. And that means there's a colossal amount of work ahead, a huge volume of software that needs rethinking, rewriting, maybe even just creating from whole new paradigms. For anyone in the industry or, looking to join, it's an incredibly unique time. Fascinating, really.
Absolutely. And to maybe give us a shortcut through this rapidly evolving landscape, we're going to use Karpathy's brilliant framing of software 1.0, 2.0, and 3.0. It's sort of like a new map, right? To understand where we've been, where we are now, and where software is heading. Okay, so if software is changing again, how does thinking in these versions, 1.0, 2.0, 3.0, how does that actually change how we build things? What are these different paradigms? What do they mean for development?
That's a great question. Let's unpack it. So software 1.0, that's the traditional code we've known for decades, right? Explicit instructions, line by line. You're writing in Python, C++, Go, Java, whatever. Think of it like giving a computer super precise step-by-step directions, like writing out every single command for a robot to assemble a specific model car. Everything's pre-programmed by a human.
Got it. The classic way.
Exactly. Then we shift to software 2.0. This came along with neural networks. Here, the code isn't something you explicitly type out line by line. Instead, the code is the neural network's weights. Billions of tiny adjustable knobs almost. And the system learns how to fine-tune them itself using something called an optimizer, basically an algorithm guiding that learning. You're not writing the instructions. You're showing it millions of examples, maybe labeled data, and it learns to do the task.
So less direct instruction, more learning from data.
Precisely. And Karpathy points out platforms like Hugging Face, they're basically the GitHub for software 2.0. You can share models, visualize them. Think of something like Flux, one of those image generators.
Right, where you type text to get an image.
Yeah. The model learned to generate images. It wasn't explicitly told pixel by pixel how to draw a cat. It learned from seeing millions of cat pictures. And now, the really groundbreaking one, software 3.0. This is where large language models, LLMs, come in. They made neural networks programmable using natural language.
Using English.
Using English, that's the astonishing part. Your prompts are the programs for the LLM. So take sentiment classification. Used to be you'd write a Python script, right? Software 1.0. Or you train a specific neural net on labeled positive-negative text. Software 2.0. Now with an LLM, you just write a prompt in English, maybe give it a couple of examples, and boom, it classifies the sentiment. It's a fundamental shift. Programming is getting much closer to just talking.
Wow, that shift sounds huge. Did Karpathy actually see this happen, this eating through the stack, as you called it, at Tesla?
He absolutely did, especially with autopilot. Karpathy watched as the software 2.0 stacked these neural networks, doing object recognition, stitching camera feeds together. They literally started replacing chunks of the old software 1.0 C++ code. As the nets got better, the explicit C++ code for certain functions just got deleted. The neural net could handle it.
So the new tech literally consumed the old code.
Yeah, a powerful real-world example.
And you're saying that same eating through the stack is happening again now with software 3.0, LLMs replacing 2.0 and 1.0 code.
Exactly. And for you listening, if you're building software or even just using it heavily, it's becoming critical to be fluent in all three. 1.0, 2.0, and 3.0, they each have strengths, weaknesses. You need to know when to write Python, when to train a model, and when to just prompt an LLM.
So it's not about one replacing the others entirely.
Not entirely, no. It's about understanding how they coexist, how they fit together. You need to decide, okay, this bit of functionality that's best as 1.0, this part needs a 2.0 model, and this complex reasoning task, that's a job for 3.0. Fluidity is key.
Okay, that helps frame the evolution. Now let's dive into the LLMs themselves. Karpathy has some fascinating analogies, starting with AI is the new electricity. What does he mean by that?
It's a great analogy, really captures the structure. Think of the big LLM labs, OpenAI, Google with Gemini, Anthropic. They're like power stations. They spend massive amounts on CapEx, capital expenditure, just training these huge models. That's like building the power plant and the grid. Then there's the OpEx, operational expenditure, to actually serve that intelligence over APIs, making it available to everyone. And access is metered. We pay per million tokens used, like paying for kilowatt hours.
Right, the token system.
And just like we expect the lights to stay on, we demand utility-like performance from LLMs. Low latency, high uptime, consistent quality output.
And we've definitely felt it when that utility flickers, right? This idea of an intelligence brownout.
Oh, yeah. We've seen it. A major LLM goes down or gets overloaded, and suddenly work grinds to a halt for a lot of people. Karpathy says it's like the voltage drops and the planet just gets dumber for a bit.
Yeah.
It really shows how reliant we're becoming.
So tools like OpenRouter fit in here.
Exactly. Like a transfer switch for electricity. OpenRouter lets you switch between different LLM providers. Maybe GPT-4 goes down, you switch to Claude, or you optimize for cost. It's becoming part of the infrastructure. Karpathy also mentions a fab analogy, like semiconductor fabs. Huge capex, deep tech, centralization.
Like chip manufacturing.
Yeah, but he says that analogy gets a bit muddy because software is just so malleable. Unlike a chip fab, you can copy software easily. Its defensibility is different.
So the better analogy is?
The operating system. This is the key insight, I think. LLMs aren't just simple commodities like electricity. They're complex software ecosystems.
Like Windows versus Linux.
Precisely. You have the closed source players like OpenAI's GPT models feeling like Windows or Mac OS, and you have the open source alternatives like the Llama ecosystem feeling like Linux. The LLM itself is like the CPU, the context window. That's your RAM, your working memory. And the whole system orchestrates compute to solve problems.
Okay, I see that.
And think about apps like Cursor, the coding assistant. You can run it using GPT-4 or Claude or Gemini, just like you run VS Code on Windows, Mac, or Linux. It's the OS layer. It also feels very 1960s computing in a way.
How so?
Well, LLM compute is still super expensive. So the powerful models are centralized in the cloud, these big mainframes. And we're basically thin clients interacting over a network, using time sharing, paying for access.
Ah, like the old time sharing systems.
Exactly. We haven't really hit the personal computer era for LLMs yet, where powerful models run locally for everyone. Though, things like high-end Mac Minis running local models are maybe the first glimmers. And interacting via text. It feels like talking to an OS via a command line, a terminal.
Yeah, the chat interface.
Right. We haven't invented the universal GUI for LLMs yet, beyond just chat bubbles. There's no standard visual way to interact across all possible tasks.
That's a really interesting perspective. Now, Karpathy also pointed out something unique, unprecedented, really. Flipped technology diffusion. What's going on there?
Yeah, this is fascinating. Think about transformative tech historically. Electricity, computers, airplanes, the internet.
Okay.
They all started with governments, military, big corporations, huge initial cost, massive R&D. They only diffused down to consumers much, much later.
Right, that makes sense.
But LLMs completely flipped. They started with consumer uses. How do I boil an egg? Write a poem about my cat. ChatGPT was just beamed down to billions of people almost overnight. And it's actually corporations and governments who are lagging behind, trying to figure out how to adopt this thing that consumers are already using for everyday stuff.
So went consumer first instead of enterprise first.
Totally. It's a new kind of magical computer that helps you with mundane tasks before it gets deployed for big strategic uses that really shapes the kinds of applications we saw first.
Okay, so if these LLMs are like early O-Days, accessed by everyone, starting with consumers, that leads us to Karpathy's take on their psychology. He calls them stochastic simulations of people. What does that mean?
It means they're trained on just unimaginable amounts of text written by humans, mostly from the internet. So they absorb patterns, styles, biases. They develop these emergent human-like qualities. They're kind of simulators of human text generation. Yeah. And they definitely have superpowers. Their knowledge is encyclopedic. Their memory within the context window is perfect, far beyond any single human. Karpathy uses the Rain Man movie analogy. Perfect recall of phone books, SHA hashes. LLMs can do that with the data they've processed.
There are downsides.
Big time. And this is crucial. They have significant cognitive deficits. First, hallucinations. They just make stuff up. It's gotten better. But they don't really have a strong internal check for, do I actually know this?
Right, the making things up problem.
Second, jagged intelligence. They can be superhuman at, say, coding or summarizing complex papers, but then fail at basic logic or arithmetic that a child could do, like saying 9.11 is bigger than 9.9 or spelling simple words wrong. These rough edges you can easily trip over.
It's okay. Hallucinations, jagged intelligence. What else?
Third, what Karpathy calls anterograde amnesia, like in the movies Memento or 51st Dates.
Their memory resets.
Exactly. LLMs don't learn continuously like humans do. They don't consolidate knowledge over time or build expertise beyond what fits in their context window. Once that window slides or resets, the memory is gone. They don't inherently get smarter from interacting with you session after session. And finally, big security limitations. They can be really gullible, susceptible to prompt injection, tricking them into doing things they shouldn't, revealing data, bypassing safety filters. They might leak information if you're not careful how you use them.
Okay, so
Yeah.
they're superhuman in some ways, but deeply flawed, almost childlike in others. How on earth do we program or work reliably with systems like that?
That's the million-dollar question. And Karpathy's answer is, you don't interact directly with the raw operating system for most tasks. You don't just paste everything into ChatGPT. Instead, you build apps on top of it.
Apps?
Yeah. Think about coding. You could copy-paste code snippets into ChatGPT, ask it to fix bugs, explain things, but it's clunky. Or you use a specialized tool like Cursor, which integrates the LLM into your coding environment. It handles the context, provides specific actions. It's an application layer.
Okay, so building apps on top. What's the secret sauce?
Yeah.
What makes a good LLM app in this new world?
Good question. Karpathy highlights a few key things. Firstly, good apps handle a lot of the context management automatically. They figure out what information the LLM needs for the specific task and feed it in so you don't have to.
Makes sense? Less manual work.
Secondly, they often orchestrate multiple LLMs behind the scenes. Maybe one model for understanding the relationships between concepts, embedding models, another for generating conversational text chat models, maybe even a specialized model for suggesting code changes, diff models. The app combines their strengths.
Okay, multiple models working together.
But here's a really critical one, maybe underappreciated. An application-specific GUI, a graphical user interface.
Not just text chat.
Right. You don't want to just read pages of generated text or code. Our brains are way better at processing visual information. Seeing changes as red and green highlights in a diff view. Instantly understandable. Hitting Command Y or clicking Accept, much faster than typing, yes, please apply that change.
So the GUI helps the human verify the AI's work faster.
Exactly. It leverages our built-in GPU, our visual processing power. It makes auditing the fallible AI much faster and, honestly, more pleasant than reading endless text. And the final key property, the autonomy slider.
Autonomy slider.
Yeah. The user needs to control how much freedom the AI gets. In Cursor, you can go from simple tap completion, very low autonomy, to letting it refactor a whole chunk of code or even attempt changes across your entire project. High autonomy. Same with Perplexity for research. Quick search, deeper dive, you choose the level. The user stays in the driver's seat deciding how much rope to give the AI.
Okay, context orchestration, GUI, autonomy slider.
Oh.
That framework makes sense.
And it all points to this new cooperative paradigm. AI generates, human verifies. The whole game is making that loop generate, verify as fast and efficient as possible.
Faster verification through GUIs.
And also keeping the AI on a leash. Don't let it generate a massive 10,000-line code change. Why? Because you, the human, have to verify it. That's the bottleneck.
Right, that would take forever to check.
Exactly. So work in smaller, manageable chunks. And write concrete, specific prompts. Vague prompts lead to bad generations, which leads to failed verification, which wastes time and compute cycles. Karpathy used a neat education analogy. Imagine an app for a teacher to create a course outline. That outline is an intermediate artifact the teacher can audit. Then a separate app serves the course content to students, constrained by that syllabus. It keeps the AI focused, preventing it from just rambling off topic, getting lost in the woods.
That's a great way to put it, keeping it focused with intermediate checks. It really echoes the Tesla autopilot point again, 12 years to get to partial autonomy. Still human in the loop. Karpathy's insistence that this is the decade of agents, not the year of agents, feels right.
Absolutely. It reinforces his Iron Man analogy. We should be building Iron Man suits augmentations where the human, Tony Stark, is firmly in control, enhanced.
Not fully autonomous Iron Man robots that just go off and do their own thing.
Precisely. Focus on products with fast human generation verification loops, enabled by great GUIs, and always with that crucial autonomy slider. Augment humans, don't try to replace them wholesale just yet.
Okay, shifting gears slightly, another really exciting implication Karpathy touched on. If programming is moving towards English, does that mean, well, everyone is a programmer now? He mentioned vibe coding.
Yeah, vibe coding. It's this idea that you can build custom, unique apps really quickly just by kind of winging it with natural language prompts. You don't necessarily need years of deep programming study to get something working. Karpathy gave personal examples. He built a basic iOS app in Swift without actually knowing Swift.
Yeah.
Just by prompting an LLM?
Seriously?
Yeah, and he built another app, Menu.app, to generate images based on restaurant menu items, built the core logic in like a day. The LLM made the coding part remarkably easy.
That sounds amazing. So easy prototyping. But you said MiniGen hit a snag, making it real.
Exactly. Getting the core AI generation working was the easy part, but then making it a real deployable web app. Authentication, payments, getting a domain, deployment infrastructure.
Yeah.
Karpathy said that part was incredibly hard. Took him like a week of painful manual DevOps clicking in web consoles, not coding, just clicking buttons. He was like, what the hell?
So the traditional software infrastructure hasn't caught up to the ease of AI development.
Pretty much. And that leads directly to his next point. Maybe we should start building for agents.
Building for agents, as in for AIs to consume.
Yeah. Think of agents as this new category of user. Not quite human, not quite traditional computer program. These human-like computers, or people spirits as he sometimes calls them, that consume digital information. So how do we make things easier for them?
Okay, how?
Well, instead of just robots.txt for web crawlers, maybe websites need an lm.txt. A simple markdown file that tells visiting LLMs, here's the main content, here's the key info, making it way easier than trying to parse complex, messy HTML and JavaScript.
Like a cheat sheet for LLMs visiting your site.
Exactly. And look at documentation. Services like Vercel, Stripe, they're already moving their docs towards clean markdown. They're replacing instructions like click this button with actual curl commands.
Because an agent can execute a curl command, but it can't easily click a button in a screenshot.
Precisely. We're making documentation LLM-friendly, agent-friendly, and tools are popping up too. Things like get-ingest for GitHub repos. It just concatenates all the code into one massive text file, perfect for feeding into an LLM's context window. Or DeepWiki from the Devon folks, where an AI actually reads a code repository and automatically rates documentation for it, specifically formatted for other LLMs to understand easily.
Wow, AI writing docs for other AIs.
It's all about meeting the LLMs halfway. Even if they get much better at navigating websites designed for humans, it's still way more efficient, way cheaper in terms of compute, to just give them the information directly in a format they can easily digest.
Okay, so pulling all these threads together, this whole shift, software 1.0 to 3.0, LLMs as OACs, their weird psychology, building apps, building for agents. What's the big takeaway for you, our listener?
I mean, the big picture is we're in an incredible, maybe slightly chaotic, but definitely exciting time to be involved with software. There's just a massive amount of work to do, rewriting old stuff, building entirely new things, using these paradigms. Remember those analogies. LLMs are like utilities, maybe a bit like fabs, but most profoundly, they're like operating systems in their very early days. Think 1960s computing, but evolving much faster. And crucially, remember, they're these powerful but fallible people spirits. We have to learn how to work with them, leveraging their strengths while mitigating their weaknesses.
Right, not just treat them as magic black boxes.
Exactly. So we need to adjust our infrastructure, build things that are easy for agents to consume. We need to build products, those apps, that enable partial autonomy with really good GUIs for that fast human AI verification loop. That autonomy slider is key. Keep the human in control. Remember Karpathy's conviction. This is the decade of agents, not the year. And the Iron Man suit analogy, build augmentations, not autonomous robots just yet. Focus on making humans faster, smarter, more capable.
So as you, our listener, step into this new era of software, maybe the question to ponder is, what will your Iron Man suit look like? How will you navigate that balance between human control and AI assistance, between augmentation and autonomy in the software you build, or maybe just the software you use every day? Think about where you can apply these new paradigms, these new tools, keeping in mind both the incredible power and the unique limitations of these emerging people spirits. The future of software is being written right now, and you really do have a front row seat to help shape it.